Welcome back to the rest half of today's course. So yeah, this weather is very nice and I struggle to get out from my bed every morning right now. Yeah, yeah. I guess some of you can feel I feel a bit lazy today. Yeah, this weather is make people sleepy. So don't worry, I feel sleepy as well. Okay, but we still need to come back here and finish our course. So let's have a quick recap about what we talked about before the break. So we talk about more uses about pointers. We talk about how we can use pointers as argument of a function. We also talk about how we can use pointers as the return type, return value of functions. And to use pointer as arguments and return value of the function, there are also a lot of small but I would say important detail to pay attention to. For example, for the argument here, we need to make sure that the type of the argument match the type of the parameters. And we need to know where should I apply indirection operator and when should I apply address operator and when I shouldn't apply the indirection operator. And I will say the trick is that please remember, have a clear understanding about what is the effect of indirection operator. So indirection operator can only apply to pointer variable, so any pointer. And the effect of indirection operator is to get the object this pointer point to. So that is the definition of indirection operator. And the definition of the address operator is to get the address of this operator. And we need to make sure the address of this variable. And we need to make sure that the type of this variable match the type that this pointer variable can point to. So if this pointer is an integer pointer variable, it can only store the address of any integer object. So it cannot store the address of the float variable or float objects. So that is the rule of C. So please remember that. And after the break, what I'm going to talk about, before I introduce anything more, I designed 2 slides to test if you understand what we talked about before the break. So the first question is here, so please check out the C code here. Here we have a function called update value, and the parameter of this update value function is an integer pointer variable. And what this function can do is to update the variable to have the new value 10. So if I want to use this update value, what should I pass to correctly update the value of non-variable to 10? What should I pass? What should I put in the argument list of the update value function? And I will wait until we have 40 submissions. Okay, we still need 4 more. 2, 1, very good. So, okay, and every time I feel a bit nervous before I check out the results, because if a lot of people choose the incorrect answer, that means that I fail you guys, okay? I didn't explain all the things clearly enough to let you guys understand. So here we go. Oh yes, very good, very good, very good. So I would say over 70% of the submission choose the correct one. Very good, very good. Oh, phew, okay. So yes, the correct answer is the and noun. So let's go back to this function, go back to this program to see why the correct answer is and noun. So in this case, we can see that we have a noun variable, right? The name of the variable is noun. And the initial value of noun is 5. Then I want to use this update value function to assign value 10 to noun. And first, what we need to check is the parameter of this update value function. The parameter is a pointer variable, and this pointer variable can point to an integer object. And so what we need to do is to make this value PTR pointer variable point to noun. So after we do that, we can use the statements in the functions to assign value 10 to the objects where value pointer point to. So we need to make a value pointer point to noun. So how to make a pointer point to another object? So the only way is to assign the address of the object, to assign the address of the variable to the pointer variable, so that we can make this pointer variable point to that variable. So how can I get? So now what I want to achieve is to make value PTR point to noun. So how can I get the address of noun and then assign the address of noun to, how can I get the address of noun variable and then assign this address to value PTR? So to get the address of noun is to apply the address operator, the AND operator, to noun. And then if we put the noun inside the arguments of this update value code, you will just copy the value of the address of noun and then assign it to the value PTR. So so that is how we can successfully make the value PTR point to the variable noun. So that is why this is the correct answer. Very good. So let's try another one. And this is harder than the previous one. So if you guys can get it right, I will be very proud of you guys, okay? So the question is, we have a code, we have a program here, and your job is to choose the correct expressions for blank 1, 2, and 3. So we have a blank 1, 2, 3 here, and we have multiple correct answers here. So you need to choose which one is correct for blank 1. You need to choose which answer is correct for blank 2. And we also have the option for blank 3 here. And the goal is that we want the program, the output of this program to be 100. So the output information should be output colon 100. So if I want to do that, what is the correct expressions for blank 1, 2, 3? And I want to give you guys more time to think about this. So let's wait until we have 50 submissions. And please feel free to discuss with your friends sit beneath you or discuss with your classmate. believe we have more than 50 today. So now we just need 5 more, 4 more, 3, 2, 1. Okay, great. Let's check out the results. It's okay. So let's explain it one by one. So for the first blank, it's very good. So over 80% of the people choose the correct answer. So for the first blank, yes, we need to pass the address of variable I to the get multiplier. Okay, it's very hard to pronounce. To pass the address of I to the function here, so we need to apply the address operator to I. So let's check out the second blank. So what we want to do in this function is that we multiply the value pointed, the value of the object pointed by input by label. I know it's a long word, but you get what I mean, right? So here what I want to do is that I want to multiply label with I, but instead of just passing I into it, I pass the address of I. So it means that this input pointer variable now points to I. And then since I want to multiply the value of I by label in this function, I need to get the value of I through the pointer point to I. So what I need to do is to apply the indirection operator to the pointer variable point to I. So we know that input point to I. So we just apply the indirection operator on input. So this start input is alias for I. So here I just successfully multiply I by label here. So and I stored the return value into VAL, this static local variable. And what I want to return, the return type of this function is also integer. Is also a integer pointer variable. Is integer pointer. So what I need to return need to be the integer pointer. So what I return is the address of VAL, because the address of a variable is the pointer to the variable, and VAL is an integer variable, so its address is an integer pointer as well. Okay, so I will encourage you to just try to implement this short program by yourself, and really to make sure you understand why this expression are the correct expression to this blank. And what you can do more is to try to modify this program by yourself and to see how you need to change those expressions. Okay, so the next thing I want to talk about is the pointers. The pointers, and okay, I really need to let the department office know the problem of this mic. Okay, so the next thing I want to talk about is how we can use pointers with array. So actually pointer can also point to array elements. For example, in here, if A is an array, we have different elements here, right? We can actually apply the address operator to one of the elements. And this will be a pointer to the element I of A. So we can get the address of AI by applying address operator. And this is also useful for a function that if we want this function to return a pointer to one of the elements in the array. For example, in this find middle function, the first parameter is array A, and the second is an integer variable n, and n is the length of array A. And what this find middle function wants to do is to return a pointer to the middle of element A. So we can just calculate what is the index of the middle element of array A, and then I just return the address of this element. So I can do that, and the return type of this function, because one element in the integer array A is also an integer variable, right? So this should be an integer pointer. So the return value of this find middle function need to be the integer pointer. So actually C allows some special things when we use pointer to point to array element, and we will call this pointer arithmetics. So arithmetics is 运算 in Chinese. So addition and subtraction are all one of the arithmetics. And actually C provides us another way to process an array. So we can actually use pointers to point to different elements of the array, so that we don't need to use index of the array anymore. We can use another pointer point to the different element of the same array. And you will see that the relationship between the pointers and array in C is pretty close. So there are a lot of more advanced skill of how you can use pointers to manipulate your array. So first, let's check out how we can use pointers to point to array element. For example, here I have array A, and the length of A is 10, and I have integer pointer, that is P, and we can use the following statement to make P point to A0. And here we are just assign the address of A0 to P. So P now is pointing to A0 here. So after we finish the second line, we can now access A0 through P, right? Because I just need to apply the indirection operator, I can get the object pointed by pointer. So star P will become A0 here, and I can assign 5 to the star P. So this is the same for, so this statement is the same with the statement that I assign 5 directly to A0, but just in this case, I use P to access A0 instead of the index A0 itself. And the next thing I want to do is that, okay, now I successfully assigned a value to A0. Now I want to point to another element in array A, but how can I make this pointer variable P point to other elements in array A? To do that, we need to perform pointer arithmetics on pointer P. So let's check out how we can do. So for the pointer arithmetics, we have 3 forms. The first one is that we can add an integer to pointers. The second is we can subtract an integer from a pointer. The third one is we can subtract one pointer from another pointer, as long as these 2 pointers point to the same array. So let's check out how to do that. So the first one is we can add an integer to a pointer. So here, for example, I again make P point to A0 here. And if I add an integer value, J, integer variable J, or any integer value to P, it will make P point to the element J places after the one P point to. For example, in this case, P originally point to A0, right? So if we add J to P and the value of J is 1, then it will make P point to A0 plus J. So this is how it works for the first pointer arithmetic. So let's check out the image here so you have a better understanding about what happened here. So here in this case, I make P point to A2. So A2 is here. Then I just add 3 to P, and then I assign the return value to Q. So if I add 3 to P, we make P point from here to here. Because if we add 1 to P, P will point to here, point to A3. If we add 2 on P, we can make P point to 2 plus 2, that is 4. And if we add 3 to P, we make P point to 2 plus 3, that is 5. And then we assigned this address to Q, so that is why in this case, Q is now point to A5. And then we can just use the compound assignment here. We can add 6 to P, and then we assign the new pointers to P again. So we just basically update where P is point to. So we can just calculate 2 plus 6 is 8. So after this statement, P is now point to 8, 8. Okay, it's very confusing now, but it's point to here in the 8th element. So this is the same for the subtraction. So if we subtract an integer from the pointers, we just also make the pointer point to different elements in the same array. For example, now P is point to the 8th element, right? And if we subtract 3 from 8, it will be 5. And we just assign this location to Q. So that is why Q right now is point to A5. Then I can do the same thing, that is I use the compound assignment. I subtract 6 from P. And then I update this value to P. So that is why after the last statement here, P right now is point to 8 minus 6, that is 2. So P is point to the 2 element right now. So the final one, what I want to introduce is to subtract one pointer from another pointers. And this can also, so this is only for the situation where both pointer point to the same array. So if I do that, the result of this pointer subtraction will be the distance. And the distance is measured in the array elements. And the distance means the distance between two pointers in the same array. For example, let's check out the example here. So in the example here, I make P point to A5, Q point to A1, and I can actually subtract Q from P. So this is, if I do that, this is the same. So I can just subtract 1 from 5. So that will be 4. And I also can switch the order of Q and P. So if I just subtract P from Q, that is I subtract 1, I subtract 5 from 1. So 1 minus 5 is minus 4, right? And this one will be 5 minus 1. So it will be 4. And this is negative 4. And the following, and for the last thing, before we end today's class, there are two things I want to remind you. So these following two things is the thing you need to avoid because it will cause undefined behaviors. So the first thing is that please only perform pointer arithmetics when they point to the array element. If this pointer only point to one single variables, we cannot perform pointer arithmetics because pointer arithmetics only work when the pointer is point to array. And the second thing is that when we subtract pointers from the other pointer, we need to make sure that both pointer point to the same array. For example, in this case, Q is pointing to array A, but P is pointing to I. In this case, I cannot subtract Q from P. It will cause undefined behaviors. So please avoid these operations. Oh, okay, it's not the last. Oh, almost. So the next thing I want to talk about is, because we can subtract both pointer, right? So that means that we can do some numeric comparisons between two pointers. So in this case, if P and Q both point to the same array, we can apply relational operator and equality operator to check if they point to the same element. So here is a quick example for you guys. So here I again use P point to A5, Q point to A1. And in this case, I can to check if P is larger than Q. And this comparison depends on the relative position of the two elements in the array. And here I know 5 is larger than 1. So in this case, it is true. So it will print out the information here. So what we compare here is the index number of the elements these two pointers point to. So finally here is, if you want to learn more about the pointers and you want to practice your English, here is a really good video from Stanford CS50 here. You can check out by yourself. And that is all for today. And thank you for coming.